So welcome students. In this video, let us look at how to calculate integral powers of I. That is I power an integer. For example, what is I power 1? So I power 1 is equal to I. What is I square? I square is nothing but minus 1 by definition. I is a number whose square is equal to minus 1. Now what is I cube? I go on increasing the power. So I cube is nothing but I square into I. So I square is minus 1 into I becomes minus I. And what is I power 4? I power 4 is I square into I square, right? That is equal to I square is minus 1 into minus 1 is equal to plus 1. So I power 4 is equal to plus 1. Now if you have I power 5, I power 5 can be written as I power 4 times I, and I power 4 is 1. So 1 times I is again equal to I. So I power 1 is equal to I power 5 is also equal to I. Next, if you have I power 6, I power 6 can be written as I power 4 times I square. So I power 4 is 1 times I square, which is equal to I square, is equal to minus 1. And I power 7 is nothing but I power 4 times I cube. 1 times I cube is same as I cube, which is equal to minus I. And what is I power 8? I power 4 times I power 4. 1 into 1 is 1. So as you can see, for powers 1, 2, 3 and 4, you got I minus 1 minus I 1. Similarly, for I power 5, I power 6, I power 7, I power 8, again you got the same numbers I minus 1 minus I 1. So what is I power 9? I power 9 can be written as I power 8 times I. I power 8 is equal to 1. So again you get I as the answer. I power 10 is equal to I power 8 times I square, which is again equal to I square minus 1. I power 11 is equal to I power 8 times I cube. I power 8 is 1. So it is same as I cube, which is equal to minus I. And I power 12 is same as I power 8 times I power 4, which is again same as 1. So as you can see, after every 4 steps, the values repeat again. So correspond to I power 1, you got I. So if you increase the power by 4, again I power 5 is equal to I. If you increase the power by 4, again the value is I. That means you get same answers for integral powers which differ by a multiple of 4. So this is the pattern which you need to observe. So the power of I, the value of power of I repeats after 4 steps. So now let us try to write this in a nice tabular form. So in this table, you can very clearly see what is happening as you increase the powers of I. So I minus 1 minus I1, I minus 1 minus I1, I minus 1 minus I1, and this pattern continues. So can you write this pattern in a nice mathematical form? So can I write it like this? If you have I power multiples of 4, that is 4, 8, 12, 16, 20, so on, these are nothing but the powers which are multiples of 4. So if the power is a multiple of 4, you'll always get 1 as the answer. And if the power is a multiple of 4 plus 1, that is 1 greater than a multiple of 4, that is you got 1, 5, 9, so on. This is 4 into 0 plus 1, this is 4 into 1 plus 1, this is 4 into 2 plus 1, so on. So if you have I power a multiple of 4 plus 1, you get I as the answer. You always get I as the answer. So what is I power? 4n plus 2. So we have I power a multiple of 4 plus 2, you get minus 1 as the answer. And if you have I power 4n plus 3, so this can be written as 4 into 0 plus 3, 4 into 1 plus 3, 4 into 2 plus 3, so on. So these are the powers of 4, which are 4n plus 3. So when you have this power, you get minus I as the answer. So as you know, 4n plus 3 can also be written as 4n minus 1, both are same. So you can consider 3 as a multiple of 4 minus 1 or a previous multiple of 4 plus 3. So this is something which you need to understand. So depending on the relation of 4 with the index, you get different answers. So now once we understand this, so let us see how to calculate the powers of I when the power is a large number. So let us take an example. So you are asked to calculate I power 257. So if you are asked to calculate I power 257, what you need to do is, so you have to try to express this 257 with respect to 4. So as you know, the number which is very close to 257, which is 256, is a multiple of 4. And this is a multiple of 4 plus 1. So this is I power 256 plus 1. So what I'm doing is a number, I have separated the number which is a multiple of 4. So I power 256 plus 1, that is equal to I power 256 into I power 1. Because 256 is a multiple of 4, I power 256 will become equal to 1 into I is equal to I. So this is how you simplify the number I power 257. So effectively what you need to remember is you can take as many 4s as possible from the power. The answer does not change. So if you have I power 1, 2, 3, 8. I power 1, 2, 3, 8. So what you need to think is you can take off any number of 4s from this 1, 2, 3, 8. So 1, 2, 3, 8, you know that it is 1, 2, 3, 6 plus 2, where 1, 2, 3, 6 is a multiple of 4. This is 4 times 309. So 1, 2, 3, 6 can be separated and that can be written as equal to 1. So this is I power 1, 2, 3, 6 plus 2. That is equal to I power 1, 2, 3, 6 into I square. So I power 1, 2, 3, 6 is equal to 1. 1 into I square is I square, which is equal to minus 1. So I hope you are understanding what you need to do. So you can do it directly also if you want I power 127. So you just need to take 124 outside because 124 is a multiple of 4. So if you take off 124, you're left with 3. So I cube will be equal to minus 1. So I hope you have understood how to simplify I power a large integer. The technique is that you can remove as many 4s as possible from the power and you'll be left with a very basic power which you know the answers for. For example, let us take I power a negative integer power. Let us see what you can do. So if you have I power minus 3, I power minus 3 if you want to calculate this. So what you can do is, as we have taken out as many 4s as possible, you can add as many 4s as possible. That is, this is same as I power minus 3 times I power 4, because I power 4 is 1. So I can always multiply this with 1. That is equal to I power minus 3 times I power 4 is I power 1, which is equal to I. So I power minus 3 is exactly same as I. What is I power minus 22? So if you want to calculate I power minus 22, take the closest power to 22. So you have 24 as a multiple of 4. So what I do is I power minus 22. I'll multiply this with I power 24. I can do this because I power 24 is equal to 1. That is equal to I power minus 22 plus 24 is I square, which is equal to minus 1. So from the positive power, as you can take off as many 4s as possible, for a negative power, you can add as many 4s as possible. So the answer can be found out by this method. Otherwise, you can also use the method of 4n plus something. So if you have I power minus 257. So what can I write minus 257 as? Minus 257 can be written as minus 260 plus 3, right? So this can be written as I power minus 260 is 4 times 65. 4 times minus 65 is minus 260 plus 3. So this power is of the form 4n plus 3. So that is same as I cube, which is equal to minus I. So I power minus 257 will be equal to minus I. So this is other way to solve I power minus 257. So you can express this as 4n plus 1, 4n plus 2 or 4n plus 3. And once you do that, you can get the answer. Otherwise, what you can do is, you have I power minus 257. You can write it as 1 by I power 257. Now you have got a positive power. That is equal to 1 by. So from 257 is a positive power. So I can take off as many 4s as possible. So I'll take off 256. So I'll left with I power 1. So 1 by I. So that is equal to 1 by I. So I'll multiply and divide it with I. That is equal to I by I square is minus 1. That is equal to I by minus 1, which is equal to minus I. So you got the same answer. You got the same answer whatever method you do. So you can directly take this to the reciprocal, consider a positive power of I, then take off as many 4s as possible, and then you multiply and divide with I, you get the same answer. Otherwise, you can express this as a multiple of 4 plus 1 plus 2 plus 3 so on, or you can add as many 4s as possible and you can use this method. So I hope you have understood how to raise I to a positive integer power and a negative integer power. Now let us look at an important property of the powers of I. An important property of integer powers of I is the sum of any 4 consecutive powers of I will always be equal to 0. Sum of any 4 consecutive integer powers of I is equal to 0. That is, if you have I power some integer plus I power an integer plus one next integer plus I power m plus 2 plus I power m plus 3. So if you have 4 consecutive integer powers of I, if you are adding all those, this will always give you 0. So you can analyze this very easily. So if you take the powers of I, they repeat after every 4 interval. So I minus 1 minus I1, 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 so on. These are the consecutive powers of I. So take any 4 starting from any point. Take any 4 consecutive multiples of I. You can see that the sum is equal to 0. So you can start with any number. If you take 4 consecutive powers, the sum will always be equal to 0. I minus 1, 1, minus 1, 1, minus I. So any 4 consecutive powers, if you take the sum, it will always be equal to 0. So this is a way in which you can observe what is happening. You can also derive this, because if you want this expression is nothing but I power m times 1 plus I square plus I cube, right? That is equal to I power m times 1 plus I minus 1 minus I, which is equal to 0. You can prove it in this way also. The sum of any 4 consecutive powers of I will always be equal to 0. So for example, if you are asked to find sigma r is equal to 1 to 15 I power r. What is this? So you know what sigma is? Sigma is a symbol for continuous summation, and r is the sigma variable, and this r is moving from 1 to 15. That means, so when r is equal to 1, you have I power 1. When r is equal to 2, you have I square. Next I cube. Next I power 4. So on. You go until I power 15, and you are summating all this. That is, you have to add all this. Now what is the sum of this? So you can use this property. Sum of any 4 consecutive powers of I is equal to 0. Now how many terms does this have? It has 15 terms, right? So if you try to pair them into sets of 4. So will it give you a complete pairing? No, because 15 is not a multiple of 4. So if you just go on pairing 4 and 4 and 4, obviously 12 elements will be paired, 3 elements will be left out. So you can start your pairing from the starting. You can start your pairing from the end also. So let us start pairing from the end. So let me take 4 numbers, and let me take the next 4 numbers, and let me take the next 4 numbers. As you see, 3 powers will be left out, because if you take pairs of 4 and if you take 3 pairs, so you can cover 12 elements, but in this sequence you have 15 elements. So 3 elements will be left out. So if you start from back, the first 3 elements will be left out. If you start from the front, the last 3 elements will be left out. So for convenience, let me start from the end. So obviously this will be equal to 0, this will be equal to 0, this will be equal to 0. These are the left out things. So you get I minus 1 minus I, this and this gets cancelled. So the answer is equal to minus 1. So I hope you have understood what we're doing. So let us take another example. This question, you're asked to find the possible values of I power n plus I power minus n if n belongs to integers. So how many possible values are there for I power n plus I power minus n? So I power n plus I power minus n is nothing but I power n plus 1 by I power n. So the value of this expression depends on the value of I power n, right? And I power n, as we have seen, can take 4 possible values. So if n is of the form 4m, n is of the form 4m plus 1, n is of the form 4n plus 2, n is of the form 4m plus 3. So depending on what the form of the power is, you get 4 different values for I power n. So if n is equal to 4m, I power n will be equal to 1. So this expression will be 1 plus 1 by 1, that is equal to 2. Now if n is of the form 4m plus 1, value of I power n will be equal to I. So you have I plus 1 by I, that is equal to I. 1 by I, as we have seen, will be equal to minus I, which is equal to 0. It means the value of this can be equal to 0. So if it is of the form 4m plus 2, I power n will be equal to minus 1. So minus 1 plus 1 by minus 1, which is equal to minus 2. And if n is of the form 4m plus 3, I power n will be equal to minus I. So minus I plus 1 by minus I is equal to minus I plus I, which is equal to 0. So these are the 4 different values possible for this expression. But as you can see, these two are same. So effectively, the possible values are nothing but 0, 2 and minus 2. So that's the answer to this question. Thank you.